So we will start our discussion on packed arrays and unpacked arrays in system verilog. So basically, these packed arrays in system verilog, packed arrays are the arrays in which all the elements are stored in a contiguous block of memory. So in case of packed arrays, the elements are stored in a contiguous block of memory. So this means they are tightly packed bit by bit, which allows efficient bit level manipulation. So let us see a diagrammatical way how these packed arrays look like. So basically, packed arrays are arranged like this, right? So packed arrays are stored in a contiguous memory location. So every element will be stored in same location. Okay, so there will be, in case of normal unpacked arrays, every element will have separate memory location like this. Vertically, it will have. But whereas packed arrays, everything is arranged in the same memory location. It is called contiguous memory locations. Contiguous memory locations. This is packed array. Okay. So in the definition also they have written, so in system verilog, packed arrays are the arrays in which all the elements are stored in a contiguous block of memory. This means they are tightly packed bit by bit, which allows efficient bit level manipulation. So everything is packed in the same location itself. Okay, every element is packed in the same location. So packed arrays are typically used when you need to manipulate the entire array as a single unit, particularly for tasks like bit slicing or packing or unpacking the data. Okay, we will see this in our next slides. Next, key points about the packed arrays are contiguous memory location. So all the elements of a packed array are stored contiguously in the memory. This allows the entire array to be treated as one scalar value. And yeah, so let's see the representation of this packed array, how to declare a packed array. So first rule is we cannot use the data types like int or byte or let's say short int, and also we cannot use long int. These data types we cannot use with our packed array. Okay, this type of data types we cannot use with our packed array. Okay, we can only use bit, logic, or rig. We can use this type of data types with the packed arrays. Okay, so this is the first condition we need to remember. Okay, we cannot use int, byte, short int, long int with the packed arrays. We can use the data types like bit, logic, reg with the packed arrays. Now let's see the representation of this packed array. So we can use anything, any of these three data types: bit, logic, reg. So I will use bit. So this is a data type followed by the size of the packed array, size, followed by name of the packed array, name. Okay, so this is a syntax for packed array. This is a syntax for packed array. So let's take an example. Bit, let's say the size is 1 down to 0, and the name of the packed array is, let's say it is packed array, packed underscore array. So this is a packed array of bit data type and the size is 2 bits. So the representation of this array will look like this. This is the array consisting of only 2 bits. This is packed array. It will contain bits. Okay, so generally packed arrays are used to represent in bit level only. So that's why we are going to use the data types bit, logic, and reg. So if you want to represent any packed array of logic data type, you can simply write data type logic followed by the size of the packed array, let's say 3 down to 0, 4 bit, followed by some name. Okay, let's say pack. So this pack array has 4 bits in it, like this, stored 1, 2, 3, and 4. Okay, of logic data type. Is it clear? Up to here, is it clear? Can anyone confirm me?
Yeah, it is clear.
Yeah. Now, so up till now we have discussed only 1D arrays, 1D packed array. Now tell me one more thing. Let's say I will declare one packed array, bit 1 down to 0. Let's say A. So this is a packed array, right? This is a packed array. And do you find it similar to the vectors in Verilog? Do you find any similarity? So A is also a vector, right? A is also a vector, right? In Verilog, have you studied about vectors? Is it true? Is my statement true? So A is also a vector, right? Yes. So A is also a vector here. Okay. So 1D packed array, it is also called as a vector. Next. Okay. Next, let's see the 2D arrays, 2D packed arrays. Coming to the 2D packed arrays, in 1D packed array, we have only mentioned the size of one dimensional. In case of 2D packed arrays, we will have the size of two dimensionals. Okay. So data type followed by size of the packed array, followed by the name of the packed array. Okay. So you can use any data type. For instance, I'm using logic followed by size of first dimension. Let's say uh, logic 1 down to 0, and size of second dimension is 2 down to 0, and name of the packed array, let's say it is example. So this is a 2D packed array. It is a 2D packed array where the size of first dimension is 1 down to 0, that is 2 bit, and the size of second dimension is 3 bit. Now let's see it diagrammatically and understand how it look like. So let us draw a packed array. So here 2 down to 0 represent, sorry, here 1 down to represent 1 down to 0 represents two dimensions. So here this whole array is divided into two blocks like this. Okay. So each block has three locations or three bits. So one, two, three. One, two, three. So this is a 2D packed array. This is first dimension and this is second dimension. So in the first dimension we have 3 bits and the second dimension also we have 3 bits. So everything is represented in a single location or contiguous memory location. So it is 0th bit 1 2 0 1. Is it clear? I hope this is clear. So if you are having any doubt you can ping me or ask. Okay. Now, so let's say if I want to, okay, so first let's represent this. So it is nothing but example. How many dimensions we have? 2, followed by how many bits we have? It is nothing but 3, right? So let's say if we want to access this bit, let's say here we have 1. So how to access this? Any idea? This is 3 2. Now I want this bit to be accessed outside this packed array. So how to access this? Simple. First write the array name followed by which dimension it is in. This is first dimension and this is second dimension. So it is in first dimension, followed by which location? Second location. That's it. We will get the value. Is it clear? Sorry, this is 0. This first dimension is represented by 0. This is 1. Is it clear? Are you getting this? How to access the, yeah. Okay. Now, bit slicing and indexing. So packed arrays allow bit level indexing and slicing. For example, if you have a packed array logic 7 down to 0 data, you can access the individual bits or slices of the data. So in this example, they have given logic 7 down to 0 data. Logic 7 down to 0 data, right? So if you draw this packed array, it will look like this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So there are total 8 bits. So if you want any particular bit, let's say if you want first bit, then you can simply write data of 1 and you can access the bit. You can basically slice the packed array. Okay, you can basically do the slicing, bit by bit slicing. Okay, so like this you can access any data. So packed arrays allow bit level indexing and slicing. For example, if you have a packed array logic 7 down to 0 data, you can access individual bits or slices of the data. Or also you can, if you want the range from 8 to 876, this slice if you want, then you can simply write data of 8 down to 6. Then you will get the bits which are present from 8 down to 6. That's it. Okay. And we have also multi-dimensional packed arrays. So system verilog allows you to declare multi-dimensional packed arrays. For example, logic 3 down to 0, 7 down to 0. So how many dimensions are there in this packed array?
Two.
Right? So how many elements we have? So this array will look like this. So this is two dimensional, where how many elements we have? 1, 2, 3, 4. Right? 1, 2, 3, 4. And how many bits are there in this each element? 3 down to 0, 7 down to 0. So how many bits are there in the each element? 8 bits, right?
Eight.
Yeah. So this is how we will represent our packed array. Next. So if you want to access, let's say this element, let's say it is 0 to 7 index 8, 9. So if you want to access ninth element, you will simply write logic, sorry, the name of the array is data. So you will write data of 1, it is in first element, right? Followed by index 9. So you will get that particular bit. Okay. So this is how we can do the bit slicing and access the data from uh, multi-dimensional array, packed array. So this is all about packed arrays. So I hope this is clear, right? About the packed arrays. You can also have 3D arrays also. Let's say for 3D arrays, you can add simply one more dimension, 1 down to 0, 1 down to 0, 1 down to 0. Example. So here you have three dimensions here. Okay. So you will have, let me represent this diagrammatically. Logic 1 down to 0, 1 down to 0, and 1 down to 0 data. So this data will look like this. So you will have two elements in this. Again, it is divided into two elements. each element will have 2 bits again. Here this is of 2 bits and this is of 2 bits, and this will also have 2 bits and this will have 2 bits. Is it clear? So this is 3D array, 3D packed array. I hope the concept of packed arrays is clear. Yeah. Now let's start with unpacked arrays. So in unpacked arrays can be of any data type. So in packed arrays we have a limitation that the packed arrays should be of logic data type or bit data type, or it can be of rect data type. So in case of unpacked arrays there is no limitation on the data type. So unpacked arrays shall be declared by specifying the element ranges after the identifier name. So in case of packed arrays, the size is declared before the identifier name. Before the identifier name. Whereas in case of unpacked arrays, the size is declared after the identifier name. In this example also you can see this is the identifier name. So the size is declared before the identifier name only. Okay, so this is the size, right? So the size is declared before the identifier name only. So how to recognize whether it is a packed array or unpacked array? You can simply refer to this size or the dimensions where it is declared, whether it is declared after the identifier name or whether it is declared before the identifier name. So by that you can identify whether it is a packed array or unpacked array. Now, so unpacked arrays can be of any data type, and unpacked arrays shall be declared by specifying the element ranges after the identifier name. And unpacked array may not be so represented as contiguous set of bits. Okay. And coming to the representation of unpacked arrays, in unpacked arrays, the array dimensions are specified after the variable name, where the packed arrays, the dimensions are specified before. In unpacked arrays, the array dimensions are specified after the variable name, whereas yeah, it is repeated. And coming to multidimensional, system verilog supports multidimensional unpacked arrays where multiple dimensions are specified after the variable name. So let's see an unpacked array example. Let's say suppose int a 1 down to 0. Okay, so how it will look like? So this is an unpacked array where we have two locations. This is first location and this is second location. So can anyone tell me what is the size of these locations? Like how many bits can be stored in each location?
32.
Yes, because the data type is int. So each location will have 32 bits. Is it clear? Like this, the 32 bits will be stored. So on 32. Now tell me one more thing. So let's say in this first location, if I want to access the fourth bit, is it possible for me to access the fourth bit in the first location in the case of unpacked arrays?
No.
Yes. So it is not possible. Okay. So for that, what you should do? You should declare a packed array with bit data type. Bit A 1 down to 0. Right? Then you can store each bit in one location, or else what you can do is you can use a packed array and unpacked array combination. Like say suppose bit, if you say 5 down to 0, A 1 down to 0. So how it will look like? Then also you can not access. You will just get the particular location. You will get only 6 bit at a time. Okay, so this is also not possible. So here you cannot get a single slice. You will get at a time the whole location value. Okay, so up to here, is it clear? Can we move forward? Yeah. Next, we can also have multidimensional unpacked arrays. System Verilog supports multidimensional unpacked arrays where multidimensional dimensions are specified after the variable name. So this is a example for 2D packed array where we have used logic array underscore 2D 3 down to 0, 7 down to 0 array. Yeah. So it is of 4 rows and 8 columns. Like this, we can also use 2D packed unpacked arrays. And we can also you can also access the elements of unpacked arrays by specifying their indexes. Array name of 2 is equal to 1. We have seen that example, right, where we are accessing the elements from this unpacked array. Next, the difference between the packed arrays and unpacked arrays. Packed arrays are contiguous blocks of memory that allows bit level operations on the entire array. So packed arrays supports bit level operations on the entire array, whereas unpacked arrays store the elements separately, making them suitable for higher level data types and when individual elements need to be accessed independently. So in case of packed arrays, you can do this bit level operations. So you can access bit by bit from we can access the each single bit, we can slice the bits. But in case of unpacked arrays, if it is a higher level data type we are using, we cannot access each single bit. We can access the whole data at a time, but we cannot slice it. Okay. Yeah. Next, how to enter any elements into the unpacked array. So in system verilog, the apostrophe is used for a feature called array concatenation, which allows you to assign multiple values and unpacked arrays in a compact form. So for example, yeah, here we are using this apostrophe. So for example, we have declared a module uh, and we have declared an unpacked array 3 down to 0. So we can use this apostrophe to enter the elements into this unpacked array. Normally, if we want to enter the elements into the unpacked array, in normal method, what we have to do, we have to write the array name unpacked array followed by the location where we want to enter the element, and we will give the data. Again, if we want to enter into the next location, we will write unpacked underscore array of 1 is equal to 2. Unpacked array of 2 is equal to 3. So this is one more method available, but this is very long. Okay, so instead of this, you can use this method. So here what you can do is unpacked array, you can write the array name followed by apostrophe and concatenation braces, sorry, curly braces. So this is called as concatenation operation. So where all the elements will be concatenated and each element will be stored in consequent locations. Like first element will be stored, 10 will be stored in first location, followed by 20, followed by 30, followed by 40. Like this, all the elements will be stored in the unpacked array. And if you want to access the elements from the unpacked array, we will see that. So here two types of methods are present for access. So before that, tell me whether the entry of elements into this unpacked array is clear. It is clear. Yeah. Now let's see how to access those elements from the unpacked array. So accessing the elements of unpacked array using, we have two methods actually. One is for each loop and other is for loop. So For accessing the elements, we have two methods. One is for loop, we can use a for loop, or we can use for each loop. So this we will discuss in our next session. So before that, what is your assignment is a small assignment I want to give. So declare a 2D packed array. Inside a module, declare a 2D packed array, and uh, sizes you wish. So you can give any size, any dimension. Just try to insert some data into that 2D packed array. Try to insert data into the 2D packed array and try to access the data, like fetch the data from the 2D array. Okay, basically fetch the data, and same you can declare a 3D packed array and try to insert some data into the 3D packed array, and similarly declare a 2D unpacked array of byte data type. Similarly, insert the data and try to fetch the data out of that array. Okay, so this is a small assignment I wanted to give. So yeah, so that's all for this session. So in next session we will see how to access the elements from the pa- packed array as well as unpacked array using two methods which are available, which are for loop and for each loop. Okay, so we will discuss it. Yeah, and one more point I wanted to show here. In case of packed arrays as well as unpacked arrays, is the memory size declaration or the memory, is it fixed or it is not fixed? Any answer for this? Is the memory dimensions are fixed or not fixed in case of both packed arrays as well as unpacked arrays? Yeah. So here, in case of packed arrays as well as unpacked arrays, the memory dimensions are fixed. That is, if you declare a packed array or unpacked array, the, let's say suppose if you have declared bit 1 down to 0 ex. So here ex is a packed array of size 2 bits. That's it. It is fixed. You cannot change the dimensions of the array once it is declared. So this is fixed dimensions. The packed arrays as well as unpacked arrays are of fixed dimensions. Remember this point. We will discuss this point by comparing in dynamic arrays and queues. So yeah, that's what I wanted to tell you. Yeah. So that's all for this session. So in next session, we will see how to access the elements from the packed arrays using the two methods which are available. One is for loop and for each loop. So for each loop is a new concept in system verilog which has been introduced in system verilog. We will see what is this for each loop also. Okay. We are going to use this for each loop more often in our sessions. Okay. So that's all for this session. So if you are having any doubts or queries, you can stay and ask, or else we can end this session. Thank you.